So in the state, so in the state machine diagram, so this state machine diagram is usually useful for the project that are having hardware components, right? And if your project is having different status, so then right? So different status. So these state machine diagrams will be useful, right? So usually these state machine diagrams we can use to in order to design and understand time critical systems. So it means if your system is having different states or the behaviors or the events within a time frame, so these time critical systems are something like that, right? So, and also we can illustrate to represent how system behaviors are happening and based on different triggering points or key events, right? So you can see medical decision making system, financial analysis system, satellite communication system, and so you can have real-time PCR machines, something robots, right? I think like, so the medical decision making system. So Vihara, you might need to develop a state transition diagram, right? So then provide the semantic foundation for activity graphs, right? So you know you have these activity diagrams, right? So for activity diagrams, you can like provide some sort of semantic base, right? So these activities actually will be the key events, right? So this is a very simple state transition diagram, right? So you have states and different events. And so if we talk about the behavior of a given system or an object, right? So the behaviors would be triggering based on different events, right? For example, so if it switch on, bulb will on, something like so. So this will be the event, and this will be the behavior, right? So something like E and V, right? So if you study well, you can pass exam, right? Something like that. So usually these state machine diagrams can used to describe the behavior of either one single object or whole system, right? So you know this, when you talk about the object, we cannot forget the class, right? Because the class is the blueprint of objects, right? So although like you have this class diagram and have so many different classes, right? We don't need to develop for each and every class, right? So you will need to only focus on very significant cases, right? So for example, if your system is having different sensors, so in that case, so let's assume you have sensors, you have UI, and etc. So I think if your project is more rely on, or the main part is the sensor, so you need to develop state machine diagrams perhaps for each and every sensor, not for UI class, UI objects, right? Or you can simply, so if you have so many sensors and so many objects that have to be like consider, if you are developing this state machine diagrams for individual objects, so you can go for this whole system option as well, right? So then you need to understand why we learn these state machine diagrams, right? So you know that these state machine diagrams can model the simply behavior of the system, right? And also the state machine diagrams will clearly illustrate the discrete systems behavior also, right? So usually, although now we are using state machine diagrams for computer world, right? So these state machine diagrams were actually came from mathematical modeling. So these are the elements of the state machine diagram. So these are the elements of state machine diagram. So we can have different status, transitions, state activities, some cases, controlling transition. Some times we can have this composite and nested states, and we can have this parallel work where concurrency and control, right? But usually we have this states transition, right? These are like will have in a state machine diagram, but not in the most all cases. So as I mentioned, so in the state machine diagram, we have made two components, right? In order to be a state machine uh, diagram, you need to have states and transitions, right? So you can see on state of the timer, off state of the timer, right? So in some cases, if we take like you are having a blood pressure sensor, right? So it can have status something like getting blood pressure, and in some cases you can have off, of course, on. Let's say error. So these kind of states there can be, right? So the transitions are something that help to change the states, right? Something like activity, right? Switching on, right? Reading the data, those kind of things, right? Switching on, switching off, this kind of will be fallen as this transitions, right? So more on these states and transitions, right? So states could be either, so usually states is the some sort of behavior of the object or the system, right? So you can have different properties and values, right? So so attributes is something like frame rate, speed, likewise. So the relationship will be how the states are like are strongly happening, etc. Right? And these behaviors or the states can have different values. So for example, if you are like dealing with numerical values, so you can have something like some cases true, false, right? Ones and zeros, etc. Right? So like as a concept, we believe or we say that object will be in a state for a time period, right? So for example, you can see, so I have taken the telephone, right? So when the telephone is first, uh, so this telephone is actually the wired connection, right? Lanka bill, SLT, those kind of things, right? So when the people come and install the telephone, so usually it's in the idle state, right? It's not in, so it's like there, right? So since the telephone is in the idle state or not doing any work, right? So this telephone is available for other transitions and different states, right? So the telephone is available for initiating calls or receiving calls. Call එකක් ගන්නත් පුළුවන්, call එකක් එනකම් බලාගෙන ඉන්න පුළුවන්. Right? So for example, අපි we like pick up the headset. කනට තියෙන එක උස්සලා තියෙනවා. So in that case, right? So the phone is in the dialing state. So this is headset is picked up is our transition. This is our state, right? So in the dialing state, the telephone is not accepting to read, right? So this should be there, and we can initiate a we only able to initiate a conversation, right? So likewise, you can have different transitions and different states, right? So you can have, although like we have so many states or so many transitions that can happen for the given object or in the here telephone, right? So you can see based on the state, some should not be happen, but some has to be happen, right? So this understanding we need, right, in order to debug your system. For example, your phone is in the dialing state and with somehow phone get ring. So that should not be happening because you are in the initial, you only can the initiate a conversation. Telephone call එකක් ගන්න විතරයි පුළුවන් වෙනෝනේ phone එක ring වෙන්න ඕනේ. phone එකට calls එන්න බෑ. So in that case, if your telephone is getting telephone calls or the receiving telephone calls when the telephone is in the dialing state, it means there is some error, right? So when the object is in any sort of state, right? So we can actually either execute event, right? For example, so when the state is dialing, right? So I can dialing state, right? What I can do, I can initiate a conversation. So if my telephone in the idle state, I am waiting for an event, either to pick up the headset, receive a call. Right? And in some cases, fulfill conditions. For example, so you are taking some, let's assume temperature, right? Temperature value for a 10-second time period, right? So in that case, the object will be in the given state in 10 seconds. In order, it's some sort of condition, right? So if you are developing some mechanism to the water level tank, right? So let's assume this is the max, right? So water comes and you develop some sort of sensor, right? It can detect if the water level is to this point, so it can be, right? So this sensor or this object will wait until the water reach max level, right? So this is the fulfilling the condition, right? So the states we can represent with rounded corner rectangles. So we can have simple, pseudo, initial and final state, right? So this initial, final and should be available for any sort of state diagram in this world. So the most of the cases we can have simple state and some cases we can have pseudo state, right? Then we have the transitions, right? So the transitions so the transitions transition is something movements, right, between the states, right? We can show these states by a arrow, something like this. So you have state 1, you have state 2, right? So this arrow will represent the transition, right? So each transition will connect two states. This transition, right, can happen in two different ways, right? So let's assume we have state 1 and state 2. So this is one method. So the transition can happen from one state to other state. In some cases, the transition can happen to the state to itself, right? So the various, so in the transition, right? So you can have control of initiating these transitions, right? So you can like have a completion transition, event-based transition, recursive transition, right? So the recursive is calling the transition, the calling something by itself. So the event-based means we are like waiting 10 seconds or waiting, filling max level, those kind of things, right? So the completion transition is this is a very common case. So you wait until the one transition is complete, then again you can have the second transition, right? So this can be actually automated. So for example, if you like switch on, right? So automatically after switching on, it is in the, let's assume, temperature taking place, right? So these we can do, right? So you have an example to do, right? So I will share the notes, the slides today, then you can try by yourself, right? So I'm not, I have the answer, but I'm not going to share the answer with you, right? So you have to try by yourself, and then you need to send me the answers, right? I will share this slide with you, right? So when you have a long description and when you have to draw it, so what you have to do is you have to read the entire case, and while reading, you have to understand what are the actions, events, and create the state transition table. So if I go to here, if I take first example for you, right? So initially the system is at initiated state. So here you can see I have my first state, right? Of the online booking system. The system will load the booking page for user to submit booking. So if the system is in the initiate state, it will automatically load this booking page, right? And it's waiting until this submitting booking is happening. So this would be our event. This would be our state, right? So likewise, our input state is initialized. So we are waiting actually until the submit order is happening, right? So when the submit order is happened, right? Once the user submit the order, it will transfer the booking created state. So from the initial state, it's going to be our second state, which is booking created, right? So you can here see. So I have said that. So we have this initialized state. So this one is start, right? So then we have submit order, booking created state, right? So then if we go to this one, from that state implies this booking created state. So that's why I have used it in here. Likewise, you can create, right? So this is the answer. Very simple case, right? So then you have this state activities, right? So in state activities, you can perform and like activities with the entry of the state. In some cases, you can do the activities while you are in a given state, right? Then you can, or either you can create, you can do the activity with the exit of the state. So if I show you in from this one, right? Perform an activity upon entry of the state, right? So so this is our start, this is our end, right? So when your system is start to work, it is automatically in the initialized state, right? So when your system is in the initializing state, right, it will go to do some sort of activity in order to transfer this timing state, right? So in the timing state, within the timing state, right? So you can have different sub activities, state activities. So you can start the timer, measure the duration, stop the timer. So and in some cases, right, So you can have a chance where you can have a case where you are exiting from one state to another state, and then you can do a action, right? So for example, if your water tank is filled max level, then you can stop the, let's assume, water filtering, start to beeping. So likewise you can have, right? So when you reach, you are actually in the movement that you can exit the state. So if you want to illustrate the controlling transitions, so you can simply, first thing is you simply develop your diagram, then you can see, right? I can add the conditions, right? So I have said like case that I am waiting 10 seconds, I am reading the temperature sensor. So in that case, you can calculate elapsed time or the times that you have read the temperature until it's 10. If you are having some sort of loop of your system, let's assume it's 100 times. So in that case, your condition will be something like loop count, you are checking until it's reaching 100. So this would be your controlling transition. You simply develop the transition, and inside of that you put the condition, right? And remember, when you developing your state transition diagram, right? So you need to name each and every transition, like pause, resume, off, initialize, right? The easy case is you can actually duplicate the transition names, right? You can see we have off 4 times. Then you have the composite and nested states, right? So in the composite state, so it in the composite case, your state, you have some state. Actually, this state is created from so many other sub states, right? So for example, if we take this operating, so this operating is something very higher level one, right? So inside of this operating, you can have so many sub sensors, sub states. So for example, if we take, so you have different, let's assume you have 10 sensors, so 3 sensors, right? And in your state transition diagram, you have read sensors state, but actually you have 3 different sensors, right, to read separately. But since your state transition diagram is getting more complex, so you can actually composite and create a superior level state, right? So if I like break down this operating state, right? So you can see it's having so many other substates inside of the operating what we call state, right? Then you have the concurrency and control, right? So so the concurrency is something you do parallelly, right? So in that case, you have different states, and you are actually having some sort of parallel work here, right? For example, let's take the previous example, reading sensors, right? So in here I have temperature and let's assume we have blood pressure, then we have oxygen level. So in that case, we can actually read those sensors parallel. So in that case, you can use this concurrency and control mechanism, right? So this is like the general notation, right? So the way that you can actually do. So in here you can see, if you want to move to the transition into a composite state, so you have your normal state here, and you can simply enter something like this. So if you want to exit from the composite state, which is doing this concurrency and control, right? So you don't need to connect these together, right? So you simply just draw a transition and connect to next state, right? And also there can be some situations where you are like having the concurrency, and also some cases we have to wait until one activity is complete in a parallel state, right? So you can simply illustrate it in this way, right? So this is basically representing the partial partitioning with the join and fork. So you know these join and forks, right? We have like talk in the activity diagrams, right? So in some cases, like you can see this state A is not going to this state directly. Instead of that, this particular state is also exiting. Have to exit from a composite state. So in that case, you can simply use join. Or if there is the situation where you have to insert values to two different parallel states, so you can simply use the fork, right?